All right, hi everyone. So I just want to go through your notes from before spring break to kind of jog your memory a little bit. This is what they looked like. Um, but before I actually start at the very top, I want to go to, I think it's the fourth page. So if you scroll past all this, well, you're not scrolling, flip past all this to this page. I just want to remind you of some of the vocab words that we talked about. So first of all, transversal, remember that's your line that crosses across. So in this picture here, this would be my transversal. Then you have your angle relationships. So alternate interior angles, remember they're between the two parallel lines and they're on opposite sides of the transversal. Alternate exterior angles, they're also on opposite sides of the transversal, but they're on the outside of the two parallel lines. So they're across from each other here. Then we have same side interior angles. So they're both between the two parallel lines, but they're on the same side of the transversal. Then you have same side exterior angles. We didn't really talk about their relationship all that much because there isn't a theorem that explains them. But here you have a picture of them. And then you have corresponding angles, which means that they are kind of in the same position. So if you look at both of those intersections of lines, both of these angles are in the top part. Okay. Then we have two words that we learned a while ago, but they still pop up sometimes in what we're doing now. So first of all, you have vertical pair or vertical angles. They're across from each other in the x. Remember, they're congruent. Then you have a linear pair, so two angles that are next to each other on a line. Remember, they are supplementary because a line is just a 180-degree angle, so they add up to 180. So what did we do with this? We'll go back up to the beginning of your notes. We did this in class actually, so I'm just going to skip over that. Look at this one with the snowmobile. Um, and we just named different angle pairs. So corresponding angles, there's usually the most of those. So like 1 and 5, for example, and so on. So that was that first thing. That might be a good thing to look over if you're trying to remind yourself of what's what. Then we actually got into these theorems and postulates. So remember, same side interior angles, when you have them on parallel lines and they're cut by a transversal, same side interior angles add up to 180, meaning they're supplementary. All right. Then we have alternate interior angles. You have alternate interior angles along parallel lines cut by a transversal. They are congruent. You have corresponding angles on a transversal with parallel lines. They are congruent. And alternate exterior angles are also congruent. So the only one that is not congruent is same side interior angles. Those are supplementary. Everything else is congruent. So then what did we do with that? Well, we figured out some missing angles. And we came up with equations. So for example, here on example 4, we said, okay, angle 1 is 3x plus 15. Angle 2 is 4x minus 5, and we had to find x. So we said, okay, what's the relationship between angle 1 and 2? And you guys said, well, it's corresponding. Do you see that they're in the same position? If they're in the same position, that means they're congruent. Congruent means equal. So we just set the two expressions equal to one another. Then you subtracted 3x from each side to get x, added 5 to each side to get 20. So that's pretty much all we did there in that first section. Then I'm going to, oh, yeah, here we go. We move on to section 2. We just kind of kept going. We did the opposite of what we did the first day. So the first day we were proving that angles were congruent or supplementary. Now we're proving, using given information, that lines are parallel. So we just did the opposite. So we learned some more theorems. I'm just going to skip down to this part. Now they're all just the converse of what you learned. So we learned about converses a while ago. Remember, that's when you have if P, then Q. You flip it around to say if Q, then P. So we flipped the statement around. So now instead of saying if the lines are parallel, then corresponding angles are congruent, now we're saying if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So it's been flipped around. So if you have corresponding angles, alternate interior angles that are congruent, then you know that your lines are parallel. If you have same side interior angles that are supplementary, this is the one that's different. So if angle 1 and angle 2 in this picture add up to 180, then you know your lines are parallel. And then the last one is if you have exterior angles, alternate exterior angles that are congruent, then that means that your lines are parallel. So what we did then in this picture here was we figured out which lines are parallel and what theorem. So for example, I'm just going to skip down to letter D because that's the one that's already circled. We have a measure of angle 5 and measure of angle 12 add up to 180. So we said, okay, 5 and 12, they're same side interior angles. Okay, they add up to 180. And they are along lines L and M. You can almost cover up line A here. It has nothing to do with angles 5 and 12, but L and M do. So we know that L is parallel to M, and because they are same side interior angles, the theorem we would use is same side interior angles converse. Then the last thing we did was just set up equations using that. So it says find x so that L is parallel to M. So looking at these problems here, you have one angle that's 2x plus 6, and one angle that's 130. So we said, okay, what type of angles are those? And you said they're same side interior angles. They're on the interior and they're on the same side of the transversal. We know same side interior angles are supplementary. So we're going to add them up and set it equal to 180. So we said 2x plus 6 plus 130 equals 180. Combined like terms, subtract 136 from both sides, so we get 2x equals 44. Divide both sides by 2, and you get x equals 22. Then on letter B, we had alternate interior angles here. We know alternate interior angles are congruent, so we set the two equal to each other. So 6x plus 4 equals 8x minus 8. Then we subtract 6x from both sides, add 8 to both sides, so we have 12 equals 2x, divide by 2, and we know that x equals 6. Then we just did a couple extra theorems here. We just said if two lines are parallel to the same line, then they are parallel to each other. Okay, so if you have two lines that run alongside each other, never intersect, and you have another line that's parallel to one of them, then they're all parallel to each other. And the last one we said was if two lines are perpendicular to the same line, then they are parallel. So this one makes sense because both of those right angles, remember perpendicular means they meet at a right angle. They are corresponding angles, they're congruent, therefore I know A and B are parallel to one another. We didn't do a ton with these theorems. The main thing that you had to know from this section was this right here, example 2. You had to come up with those equations and solve them. That was a big part of your quiz. That's really a quick overview of all the stuff that you learned in topic 7. If you have questions about any of this, feel free to email me or you can schedule a Google Hangout. Otherwise, hopefully that jogged your memory. You're remembering some things. The main thing that you got to know is which angle relationships are congruent, which ones are supplementary. Remember, the only one that's supplementary is same side interior angles. All right, that is it for today.